Hyperbolas are the fourth conic section that we're going to discuss, and you can see the standard form here. It's slightly different than an ellipse in that the two terms here are separated by a minus instead of separated by a plus. That's going to be the distinguishing factor between ellipses and hyperbolas. The standard form always has it equal 1, so that will be consistent. And the x squared will always be over a squared. Y squared will always be over b squared. Depending on which term is first, here in the top one, the x squared term is first. Here in the bottom one, the y term squared is first. Y squared term is first. And so we will be talking about the differences there and what that means. So the center for each of these forms is going to be 0, 0. You can see there's no parentheses with numbers added or subtracted from the x and y variables, and so we're going to have the center right at 0, 0. Asymptotes for each form are going to be the same. They are y equals b over ax and y equals negative b over ax. So as we do our example, we'll pick out that a and b by square rooting a squared and b squared. Down here, it's the same. The difference here, the vertices are going to be determined by the first term. If the first term is x squared, you are going to take your a value, which a would be the square root of a squared, and that's going to determine your vertex. So since x and a are in one fraction here, the a is going to be the x coordinate of the vertex, so it's going to be a0 and negative a0 for your vertices. Down here, since the y term is first, your b squared will help determine your vertex. And so b is going to be the square root of b squared. And since it coordinates with the y coordinate, it's going to be the y coordinate of the point. So it's going to be negative b and b for your y coordinate, and then your x coordinates are 0. So let's go ahead and apply all of this to an example and see what it looks like. Here I have an example where the x squared term is first, so that's going to be what helps us find our vertex. Here, b squared is 9, which means b is 3. So my vertices are going to be my x coordinates. I will use the 3 for, so it would be 3, 0, and negative 3, 0. My center's at 0, 0. There's nothing shifting the center left or right. And then I'll get my asymptotes. Going back up here, my a is 3, my b is square root of 4, which is 2. So as I do my asymptotes, they're going to be plus or minus b over a. So 2 over 3x. So I'm going to go on and graph those. I can graph positive 2 over 3x and negative 2 over 3x. So I'm going to start with my asymptotes. I'll do the positive one first. So my y-intercept is 0. My slope is 2/3, up 2 over 3. So as I graph these, because it's an asymptote, I'm going to graph them as dotted lines. When I actually graph my hyperbola, I'll graph it as a solid line. Now the negative one would be down 2 over 3. So there are my two asymptotes for my hyperbola. Next, I'll graph my vertices, and I'll have 3, 0, and negative 3, 0. And that's really all I have for points. Because I have these asymptotes, I do have a direction for where my line to go. Hyperbolas are going to, go through the vertex, and they are going to have to go closer to the asymptote but not touch it in this direction and this. I won't be able to go into the corner towards the center because I wouldn't be able to go closer to it but not touch it in an infinite direction. So same over here. So So the gray is my answer. When I'm asking you to graph it, I'd look for all of this information. What I did on the last slide here is I just gave you like a summary of all of the conic sections so that you can compare similarities and differences. They do have a lot of similarities, but they're each a little different, and it allows you to identify which one you are dealing with. There is a typo, it looks like. This should be a minus. But other than that, you have your circles, your x squared and your y squared terms are both squared. When you have an ellipsis, same, but you'll have a fraction. You'll have it divided by a number on one or both of the terms, and it equals 1. Hyperbolas, similarly, they equal 1, but you're looking for a minus in between the terms. And then the parabolas are really unique because they have one variable is, has a power of 1, and the other variable has the power of 2.